Tonight I'm going to go over the 2 word problems that you were assigned for homework. So our objective is I can write and solve equations involving the distributive property given a word problem. Tonight's first word problem was the cost of admission to a history museum is $3.25 per person over the age of 3. Kids 3 and under get in for free. If the total cost of admission for the Warwick family, including their 2 6-month-old twins, is $19.50, find how many family members are over 3 years old. The first way I'm going to solve it algebraically is the way New York State approaches it, because they want you using the distributive property to solve this problem. But then I'm going to show you a second solution, which would be more how I'd approach the problem. So here's what New York State says. They decided to let X represent the number of family members in the Warwick family. So they chose to let X be the total number of family members in the Warwick family. So X minus 2 would represent the number of family members over the age of 3, because you got to take away the 2 twins who are only 6 months old. And then they write this equation. They know it's $3.25 per person over the age of 3. And they know the total that they paid was $19.50. So they said $3.25 times X minus 2 is the number of family members over 3 will give you $19.50. So this is the equation that they set up. In a few minutes, I'm going to show you a different equation. So to solve this equation, the first thing we're going to do is we're going to distribute 3.25 through the parentheses to clear the parentheses. And that'll give us 3.25x minus 650. And I'm leaving it all in terms of money because I know that within this problem, the $3.25 represents money, the $19.50 represents money. That's why I chose to write 6.50 and not just 6.5. Now we're ready to undo any addition or subtraction. So we're going to choose to add 650 to both sides. When you add 650 to both sides, minus 650 plus 650, those will zero out. Those are additive inverses. So on the left, we're left with 3.25x equals, over on the right-hand side, we'll get $26. Then we say, okay, how do we solve for x? Well, the operation between the 3.25 and the x is multiplication. We undo multiplication with division. Therefore, we'll need to divide both sides by 3.25. 3.25 divided by 3.25, we know that's a fancy form of 1. So on the left-hand side, we're left with x equals 26 divided by 3.25 is 8. That's the total family members in the Warwick family. Total family members. But they didn't ask for the total family members. The word problem actually asked you to find how many family members were over 3 years old. Well, the number of family members over 3 years old is x minus 2, so it would be 8 minus 2, or 6. So that's how New York State approached this problem. And I'm thinking it's because they wanted you to incorporate the distributive property. I would have approached it a little differently, and that's what I'd like to show you here. I would have immediately let my W represent the number of family members over the age of 3, because that's what the problem was looking for. Find how many family members are over the age of 3. So that's what I would have let my W represent. Then I would have said, okay, 325 times however many family members are over the age of 3 times our W is going to equal what we pay. And then I would divide both sides by 3.25. And I would come up with 3.25 divided by 3.25, fancy form of 1. That way I have W equals 1950 divided by 3.25 would be 6, which would be the number of family members over the age of 3. And so hopefully you chose one of those equations to solve. To get your solution. You also could have done an arithmetic solution, but on the homework I asked that you include an algebraic solution as well. Let's take a look at the next problem. Now in the next problem, I do agree with New York State in terms of what they chose to let X represent and how they set up the problem. This problem really does need the distributive property. says the total number of participants who went on the 7th grade field trip to the Natural Science Museum consisted of all 7th grade students and 7 adult chaperones. So all of the students went on the field trip and 7 chaperones. 2/3 of the total participants, all of those 7th graders plus the 7 chaperones, rode the large bus. The rest rode a smaller bus. 54 of them rode the large bus. How many students went on the field trip? So as soon as it says how many students went on the field trip, that tells me what I'm going to let X represent. Let X be the total number of students who went on the field trip. Well, I know on that large bus, 2/3 of the total participants rode the large bus. So what were the total participants in the field trip? All of the 7th graders plus 7 adult chaperones. So that's X plus 7. 2/3 of them rode the large bus. So that's why I do 2/3 times X plus 7 equals how many rode the large bus, which is 54. I then go ahead and solve this equation. And as soon as I get my X, I'll have my answer because I'll have the total number of students who went on the field trip. Total number of students plus 7 extra, that's the chaperones. 2/3 of that total amount went on the large bus, so that's why it's 2/3 times that, equals how many went on the large bus? 54. So our first step is to distribute the 2/3. I am choosing to leave everything in fraction form. You don't have to. You could change things out to mixed numbers. Like if you want to change the 14/3 to a mixed number, the only thing I would say to not do is do not put everything in decimal form, because 2/3 is a repeating decimal point, 66666 repeating, and you'll have rounding to do. I would prefer you just leave it in fraction form. So once I distribute the 2/3 through, and again, 2/3 times 7 off to the side, I can remind you of that. 2/3 times 7. 7 is the same as 7 over 1, straight across the top, straight across the bottom. 2 times 7 is 14, 3 times 1 is 3. That's where I get my 14/3. Now I have to undo any addition or subtraction first. So I'm going to subtract 14/3 on both sides. 14/3 minus 14/3, the whole point, those are additive inverses, was to zero those out. So now I have to do 54 minus 14/3. So I have 54 minus 14/3. If I'm going to subtract, I have to find a common denominator. That's 54 over 1 right now. I'm going to multiply top and bottom by 3. 54 times 3. I don't have a calculator. Hopefully you do. 4 times 3, that's 12. 3 times 5 is 15 and 1, 162. So that must be 162 over 3 minus 14 over 3. 162 minus 14. 162 minus 14. 12 minus 4 is 8. 5, 4. So is that 148? Sounds good to me, right? 148 over 3. And again, you could divide that out. I think you'll come up with a whole number actually at this point, but I'm just going to leave it like that for now. So now I have 2/3 X equals 148 over 3. What's the operation between the 2/3 and the X? Multiplication. How do we undo multiplication? Division. So we'll be dividing both sides by whatever the coefficient of X is. We'll be dividing both sides by 2/3. 2/3 divided by 2/3, fancy form of 1. So we'll come up with X equals. And now, let me just erase some of this, just so we have space. And now I need to do 148/3 divided by 2/3. 148/3 divided by 2/3. I will skip, flip, and multiply. 148/3 times 3/2. 3 goes into 3 ones, 3 goes into 3 ones. Straight across the top, straight across the bottom. I have 148 over 2. How many times does 2 go into 148? 2 goes into 14, 7. 2 goes into 8, 4. So it must be 74 students who went on this trip. There you have it. 74 students went on the trip. Hopefully going through those 2 problems helped you a bit. On this one, you definitely needed the distributive property. On the other one, I wouldn't have chosen to use it, but New York State does. All right, try to have a good night.